Welcome back to Science Modernizers. Welcome back to this video. Today we are going to see the Physics Aptitude Medical Entrance Examination, the 2022 session. So let's get started with the video. Question number 76. The following pairs of physical quantities have the same base units except one, which A. Energy and torque in bracket, moment of rotation and the torsion. So the moment of rotation, so the energy E is measured in Newton meter energy. So it is force times distance. Next, the torque, that's the rotational moment, is measured in Newton meter. So the two quantities all have the same base unit. The torsion is simply the twisting of a beam under the action of a torque, and so it also has the same unit as the torque, that's in Newton meters. So this option is correct. Option B, decay constant and frequency. The decay constant lambda is given by the natural logarithm of 2 divided by t half, and t half is in second. The natural logarithm of 2 is a constant and it is dimensionless, and so the unit is the per second. The frequency is 1 divided by the period, which is also measured in per second. So B is correct. C, the pressure and Young's modulus. The pressure is the force per unit area, so it is measured in Newton per meter squared. Also, the Young's modulus E is stress divided by strain. The stress is measured in Pascal, that is the Newton per meter squared, and the strain is unitless. So the option C is correct. Now the permeability of a medium and the permittivity of a medium. The permeability of a medium is mu naught and the permittivity of a medium is epsilon naught. The permeability is measured in Henry per meter and the permittivity is measured in femto per meter. These two units are not equivalent to each other, and so the correct option is D. Question number 77. It says a mass of 4.0 kg sliding on the platform without friction has a speed of 5.0 meters per second due north. 6.0 seconds later, it is moving due south with speed of 2 meters per second. The average external force that acted on it during the interval of time is, so the average force is given by Newton's second law, F average, simply equal to the rate of change of momentum, so that will be m into v minus u, all of that divided by t. So the interval of time, delta t, was already given to be 6 seconds, and the mass is 4 kilograms, and so the object was moving initially to the north, and the speed was 5 meters per second, and after 6 seconds the object began moving towards the south, and the speed was 2 meters per second, and so this is the final speed and that's the initial speed. And so if we want to get the average force, it can simply be the difference between the final momentum possessed by the object and the initial momentum. And the momentum is the product of the mass and the velocity of an object. And so from the expression of the average force, mv is the final momentum and mu is the initial momentum. That's expanding the brackets. So if I say I have P initial, will simply be mu, which is going to be the mass, that will be 4 kilograms times the speed, which is 5, and so I will get 20 kilogram meters per second. Next, the final momentum pf due south. So we see that the velocity of the object is in reverse direction, and so it's going to be given by mv, which is going to be 4 times negative 2, and so I'm going to get negative 8 kilogram meters per second. So that's the final momentum. And so the change in momentum, or the average force, delta P, FAV, simply be given by delta P divided by delta T, and delta P is simply the final minus the initial. So that would be negative 8 minus 20, all of this divided by the interval of time, that will be 6 seconds, and so this will be negative 28 divided by 6. So this can be simplified to 3 and here 14, and so we are going to have negative 14 divided by 3 Newton. So that in decimal simply gives 4.6666 newtons. So it means the average force, F average, will be equal to negative 4.66 newton. So the negative sign indicates that the final direction of the force is definitely going to be downwards. That will be towards the south, and so the correct option there is no answer is correct, because at the end of the day we find no expression or no value of the force which corresponds to this value. And also this is the vector expression of the force, because taking into consideration the sign gives us the sense, and so the magnitude of the force is simply 4.66 newton. Still the option does not exist, so there is no option to that. There is no correct answer to this question. Question number 78. An object with a mass of 100 kilograms moves at a speed of 100 meters per second. The value of the energy increase for a speed of 5 meters per second will be, so I have a speed u, which is 10 meters per second. So the final speed v is given by u plus 5 meters per second, which is equivalent to 15 meters per second. And so the energy increase for a speed of 5 meters per second will be, so the kinetic energy K will simply be a half m into v squared minus u squared. So this gives a half times 100 times v squared, which is 15 squared minus 10 squared. So this is equivalent to a half into 100 times 225 minus 100, and so simplifying we get a half into 100 into 125. So this goes here one time, and here we are going to have it 62.5 times, and so this is going to be equal to, multiplied by 100 will give you 6250 joules. So 6250 joules is also, in standard form, will be 6.25 times 10 raised to the power 3 joules. So the correct option is option C. Question number 79. The force is acting on the point A equal to 2I and B equal to 2I plus 6J. So equal to 2I plus 6J. The particle will move along A along the x-axis, B along the y-axis, C in the xy plane, D all of the above, E none of the above. So I have two vectors A and B. So vector A, let's say relative to the origin, it's given by 2I. Vector B, relative to the origin, is given by 2I plus 6j, and so the resultant of these vectors, and we call it R, the resultant will simply be vector OA plus vector OB, and so this gives 2I plus 2I plus 6j. So simplifying, we get 4I plus 6j. Now we see that this is a point along the xy plane. So if this vector was to be represented on the Cartesian plane, we are going to get, it is a point I, J is a point 6, and I is a point 4, and so we see the point is going to be somewhere there. If it is linked to the origin, we are going to have a line segment as such, and so definitely this vector expression shows that it is not only along the x-axis, neither is it only along the y-axis. Being along the x-axis means the j component is null. Being along the y-axis means the I component is null. But since it is composed of both components which makes up the motion of the particle, so the motion is always going to occur in the xy plane. So the correct option is C. Question number 80. It reads, the length per unit resistance of a copper wire. The length per resistance unit of a copper wire has a value of 7.63 millimeters per ohm for a diameter of 1.45 millimeters. This corresponds to a resistivity of, so resistivity is the product of the resistance times the cross-sectional area of the wire divided by the length. And so this expression can still be written as the area divided by the length per unit resistance. So this is mathematically equivalent to this, so they are the same. Since simplifying this resistance will go back above, and so we can do some numerical application. Now the cross-sectional area A, so the cross-sectional area A has the expression pi diameter squared divided by 4 for the wire, and so we can get the expression, we can get the resistivity of the wire. So the resistivity of all will be pi, the diameter is 1.45 times 10 to the negative 3 in SI units, all of that squared, divided by 4 times. Now we have the length per unit resistance, which is 7.63 millimeters per ohm. That will be times 10 to the negative 3 in meters per ohm. So this ohm shall ascend, and so we get the resistivity rho will simply be equal to 2.1642 times 10 raised to the negative 4 ohm meter. And so this will be approximately, to 3 significant figures, will be 2.16 times 10 to the negative 4 ohm meter. So the correct option is option E. Next, which of the following thermometers is a standard thermometer? A, the constant volume gas thermometer. B, the mercury glass thermometer. C, the resistance thermometer. D, the radiation pyrometer. E, none of the above. The correct option is A. Question number 82. When calculated from balance length, a potentiometer difference across the first resistor of 5 ohms is 2.6 volts. The current through the second resistor of 5 ohms to the equilibrium point is ABCD. So we have the voltage drop across the second resistor will simply be given by IR. So it means the current I will simply be equal to V divided by R, which is 2.6 divided by 5 ohms, and so it gives us 0.52 amperes. So the correct option is B. Question number 83. The current in the copper wire is increased by increasing the potential difference between its ends. Which of the following statements about N, the number of charge carriers per unit volume in a wire, and V, the drift rate of charge carrier is correct? A. N is unchanged but V is increased. B. N is unchanged but V is decreased. C. N is increased but V is decreased. D. N and V are increased. E. None of the above. The correct option is option A. So since the current in the copper wire is increased by increasing the potential difference from I is equal to never, nothing was said about the material, so it definitely means we are simply increasing the potential difference across the end of a given conducting material, or let's say conducting wire as such. So increasing the potential difference across the ends A and B will in no way alter the number of electrons per unit volume inside these conductors, so it's always going to remain unchanged. But rather, what is going to change is by the action of the potential, which causes an increase in current, our electrons are going to gain energy and are going to vibrate with a greater amount of energy from equilibrium position, and hence their drift velocity is going to increase according to this relationship. When I increases, V definitely increases. So the correct option is A. Question number 84. For identical cells, whether connected in series or in parallel with an external resistance of 2 ohms, gives a current of 0.5 amperes. The electromotive force and the internal resistance of each cell are A, B, C, D. So we are going to consider both cases. We are going to take where the sources of EMF are connected in series. So if they are connected in series to an external load, we have 4 of them. We have 4 of them. Connected to an external load, and so this has a resistance of 2 ohms. This has EMF E, let's call it E, let's call this E. So the effective EMF, E effective, will simply be equal to 4E, but the effective EMF, E effective, is equal to the current into capital R plus small r. And so the external load has a resistance of 2 ohms, and this is going to be R total. So R total is going to be the effective internal resistance, and since they are in series and all of them are identical, so it means all of them have internal resistances R. And since they are in series, it means E effective, which is 4E, E effective, which is 4E, will be equal to the current 0.5 into, so my external load is 2 ohms plus the effective will be 4 times small r. And so rearranging that equation, I will multiply through by 2, so I will get 8E will be equal to 2 plus 4r. From where, if I divide all through by 2, I can rearrange this equation as 4E minus 2r is equal to 1. Call that the first equation. Now we are going to consider the case where the sources of EMF are connected in parallel to each other. So if they are connected in parallel to each other, we can have a circuit arrangement of this nature. So they are going to be connected as such right up to the external load, right up to when we will have the external load. And so there are 4 of them in number, and therefore the effective EMF will simply be E. So E effective will simply be E since they're in parallel, and so the voltage drop across each of those points or each of those terminals will be the same. So the effective EMF, E effective, is given by I into capital R plus R effective. And so the reduction of this circuit, the reduction of that circuit will give us the effective EMF, which is connected as such to the external load. I apologize for the straightness of my diagram. To an external load. So this is the effective EMF. So we see that the effective EMF or the effective internal resistance, let me say R effective, when connected in parallel is in series with the external load, reason for this one. And so we proceed by getting a second equation. So the effective EMF is E, which is 0.5 into 2 plus the effective internal resistance. That's from when it's a circuit or when resistors are connected in parallel. R effective will simply be 1 on R plus 1 on R. That will be in total, that will be 4 divided by R, and so the effective resistance will be 4. So it will be R divided by 4. Will be R divided by 4 since they are connected in parallel, and here we have R on 4. So rearranging, we get, can multiply through by 2, I get 2E will be equal to 2 plus R divided by 4. And so if I multiply all through by 4, I will get 8E minus R is equal to 8. We'll call this equation 2. So I'm going to solve this simultaneously with the first equation, which is 4E minus 2R equal to 1. So here I have 4E minus 2R is equal to 1. So I can multiply this equation by 2, which is going to give me 8E minus 4R is equal to 2. And so I can call this, that was my equation 1. So if I take equation if I take equation 2 minus equation 1, I get 8E minus 8E will simplify. So I have negative R minus 4R will be negative 5R, and 8 minus 2 gives 6. And so equation 2 minus equation 1, sorry, negative R minus minus 4R will give me positive 3R. So it means R is equal to 2 ohms. So that's the value of the internal resistance. And so replacing the value of the internal resistance in any of those equations, say in 2 I have 8E minus 2 is equal to 8, and so I get 8E is equal to 10, from where we have E is equal to 10 divided by 8, and 10 divided by 8, which is the same as 5 on 4, is equivalent to 1.2. So the correct option the correct option will be 1.25 volts and 2 ohm. So this is equivalent to 1.25 volts. So the correct option is option B. Okay. Question number 85. The temperature of two sides of a flat brick wall at 25 degrees Celsius and 10 degrees Celsius. The wall is made 3 times thicker, and one side remains at 25 degrees Celsius. If the rate of heat conduction per unit area remains the same, then the temperature of the new phase will be off. So let's get a pictorial representation of the situation. So we have a wall. Let's see, this is a typical wall. We are just going to use a general case. Okay, so with this, initially the wall had a thickness. I will call that thickness x, and the inner temperature was 25 degrees Celsius and the outer temperature was 10 degrees Celsius. And so now the wall was made 3 times thicker. So it means the thickness, the new thickness of the wall will be 3x. And so the outer temperature is, let's call it theta. So that's what we are looking for, the temperature of this new surface, theta. And so the information that was given, they said the rate of change of heat conduction per unit area is the same. And so since it is the same material, it simplifies the problem. And so we are going to use the energy equation, which says the rate of change of heat, that's dq on dt, is simply given by negative Ka times d theta on dx, where K is the thermal conductivity. Dx here represents the thickness, and dq on dt is the rate at which heat flow. And the question says the rate at which heat flow is a constant per unit area. So it means if I write dq divided by a dt, this is equal to negative K times d theta on dt. But this, according to the question, this is a constant. We can call it C. So this means that constant C is equal to negative K times d theta on dx. So on dx. Okay, now what we realize is K is the thermal conductivity, which is the property of a material, and the material too is the same, so it is homogeneous throughout its length. And so the thermal conductivity in the case of the thickness of x and the case of the thickness of 3x will be the same. And so let's identify the value, the expression of the value theta. So I used the arbitrary definition here, theta. So since our variable was theta, let's change our variable to a certain t. So let's let the unknown be T. That's the temperature we are looking for. So that we should not mix it up with this theta, because the theta is the variation of the temperature. It is the variation of the temperature, which is the difference between the inner temperature and the outer temperature. And so we have the first case. So the very first case at the thickness of x. So that's our first case. So our constant C will be equal to negative K times the variation in temperature is 10 degrees Celsius minus 25 degrees Celsius. All of this divided by a thickness of x. So this means we get negative 15 times K will give me 15K divided by x is equal to C. Call that equation 1. The second case is at the thickness. The second case is at the thickness of 3x. So at the thickness of 3x, the constant C is equal to negative K into the outer temperature theta minus 25 degrees. All of this divided by the new thickness 3x. So I will call this equation 2. Now the constant C are equal, so I can equate equation 1 and equation 2. So equating equation 1 and equation 2, I get 15x on 15K divided by x will be equal to negative k into theta minus 25 divided by 3x. And so we realize that the k will simplify. The k will simplify. K will simplify with k, x will simplify with x. And so what will be left will be, we have 15 will be equal to, expanding the brackets, I have negative theta plus 25, all of that divided by 3. So 15 divided by 3 is, 15 multiplied by 3 will give me 45. So this means 45 will be equal to negative theta plus 25. And so making theta the subject, I get theta will be equal to 25 minus 45, which gives negative 20 degrees Celsius. So it means the temperature of the other core is simply negative 20 degrees Celsius. Apologies for defining it as T. We actually defined it as T, so it means the correct option is option D. Question number 86. Which of the following statements about airwaves is true? A. Electromagnetic waves can be diffracted. B. Long Beach waves. Long Beach is now, it cannot be diffracted. C. Sound waves can be polarized. D. Radio waves cannot be polarized. E. None of the above. So airwaves are waves which can be used in broadcasting, and electromagnetic waves, for example, the radio wave, are waves that can be diffracted. So option E is the correct answer. The next is question number 87. The shortest distance between two parallel points on a traveling wave having a phase difference of 6 pi is 0.15. If the frequency of the wave is 400 Hz, the speed of the wave in meters per second is, so we have the phase angle or the phase difference phi is given by 2 pi x divided by lambda. So it means lambda will be given by 2 pi x divided by phi. 2 pi x divided by phi. And so the wavelength lambda will be 2 pi into 0.15 meters divided by 6 pi. So the pi should simplify, and 2 times 0.15 is 0.3. So 0.3 divided by 6. So this gives 0.3 divided by 6, which is 3 on 6 times 10 to the negative 1. That's 0.5. So 0.05 meters. So that is the wavelength. And so to calculate the speed, so the speed V is equal to the frequency times the wavelength, and the frequency is 400 Hz. That will be 400 times 0.05. Which is going to give 20 meters per second. So the correct option is D. Next, question number 88. When a light source is at a distance 1 meter from a photocell, the stopping potential is V. The source is placed at a distance 0.5 meters. The stopping potential will be, correct option is E. It will still be V. The stopping potential is the minimum negative voltage which is applied to the anode to stop photocurrent, and the potential, that's the stopping potential, can be gotten from the, is equivalent to the maximum kinetic energy. So EVS is equivalent to the maximum kinetic energy KE max, from where the stopping potential will be equal to KE max divided by E. So this quantity E is in EVS is measured in electron volts, and so we can get the stopping potential from here, and we see that the stopping potential is independent of distance, and so no matter how the variation of the distance is, so long as the frequency of the radiation is unaltered, V, the stopping potential will not change, so it's still going to be V. Question number 89. A gas sample has a volume of 1.5 times 10 to the 5 meters cubed and the pressure of 3 times 10 to the 5 pascals. Its new volume when the pressure is halved at constant temperature is, so we have P1 V1 is equal to P2 V2. So the new volume V2 will be equal to P1 V1 divided by P2. So this will be P1. So the pressure, now the new volume when the pressure is halved, so it means P2 is equal to a half P1. So this is equal to P1 divided by 2. And so my V2 will be equal to P1 V1 divided by P1 on 2. So the 2 will go above, so I'll have 2 times P1 V1 divided by P1. So the P1 will simplify. So this will cancel with this. So it means my V2 will simply be equal to 2V1, which is 2 times 1.5 times 10 raised to the power 5, which is going to give 3 times 10. Going to give 3 times 10 plus the power 5 meter cube. So the correct option is option C. Which of the following statements will produce a greatest increase in volume of a sample of ionizing gas in a cylinder with a moving piston when all the properties remain unchanged? A. By doubling the pressure. B. By increasing the temperature. By increasing the temperature from 50 degrees Celsius to 100 degrees Celsius. C. Doubling the number of molecules in the sample. D. Each of them will produce the same double volume. E. None of the above. So the one which is going to increase the greatest volume will be option B, as the case of temperature. As if we have molecules inside, let's say a given container, and as a piston compresses them. So when the temperature increases, what happens is all these molecules gain kinetic energy, molecular kinetic energy, with which they move and they collide with the surface, with the walls of the container with a greater force, and thereby causing a greater expansion compared to doubling the number of molecules. So the correct option is B. Two gases, question number 91. Two gases P and Q are at the same pressure. If P is at the temperature of 280 Kelvin and Q is at 630 Kelvin, the density ratio of P to that of Q is, so the very first is we have the case of P. So the pressure P in general, as an equation of state, is given by rho RT. So the pressure of P will be rho of P times R times T of P. Now for Q, the pressure of Q will be equal to rho of Q times R times T Q. And so, but the pressures are the same. So it means PP is equal to PQ. And so we get rho P times RTP will be equal to rho Q times RTQ. So doing some little cancellations, R will cancel out with R, since R is the molar gas constant. And so we get the density of P to that of Q to be equal to TQ over TP. So TQ is 613 divided by TP, which is 280. So the zero simplify, and 7 cancels 63 9 times, and 7 cancels 28 4 times. So it means density rho P and rho Q, it's 9 on 4, which is actually what is demanded. So also the density of Q with respect to that of P is to have the density of Q to that of P, which will give us option A. For transistor, question number 92. For transistor actions, A. The collector should be heavily doped than the issuer. B. The base region of the collector must be reverse biased. C. The base region should be white. D. The transmitter must be of type N. E. All the answers above. So for transistor actions, the junction must be lightly doped so that the base region is very thin, and also the emitter junction must be forward biased and the collector junction should be reversed biased. So the correct option here will be option B. The base region of the collector must be reversed biased. Option B. Question number 93. It reads, on the surface of a planet of radius r, the force F due to gravity undergoes a force F due to gravity. Now the question is, what force does it experience when it is moved to a point at a height of 1/3 from the surface of the Earth? So the pictorial representation of the problem is, I have, let's say that's my planet, and I have the object at that height. So the distance from here right up to that point is r, and the distance from here right up to where the object is 1/3 r. So the total distance from the center of the Earth right up to the point will be r plus r on 3, which is going to be 4r on 3. And so I want to get the expression of the force. So at that point, now on the Earth's surface, the force F is Gm. We are going to let the mass of this small object to be small m divided by the radius square, r squared. So call that F naught. And so this is the radius of the Earth, E. And therefore, at that height, F is going to be Gm divided by 4/3 r, all of that squared. And so adjusting this numerically, we get 9 Gm times small m divided by 16 r e squared. And so this is this expression, it's F naught. And so we get it to be 9 divided by 16 F naught. And 9 divided by 16 in decimal is approximately 0.56. So we have, this is 0.5625 F naught. So that will be the new intensity of the force. So the intensity of the force felt by the object at that height will be 0.5625 F naught. And so checking the best matching option, the best matching option is option D. Option D. Number 94. An electron beam passes without deflection through a region in which exist mutually perpendicular electric and magnetic fields of magnitude 10 volts per meter and 0.02 teslas respectively. The speed of an electron beam will be, so we have the equilibrium of forces felt by the electron as it is moving undeflected will be given by EQ, which is the strength of the electric field, be equal to B eq of V, where V is the speed or velocity with which the particle or the electron beam is moving. So the charges will simplify, and B eq of V is the expression of the magnetic force. So cure, simplify. So it means V will be equal to E divided by B, from where we have 10 divided by 0.02, which is 10 on 2 times 10 to the negative 2, and this gives 1002, which is 500 meters per second. And in standard form, this is 5 times 10 to the power 2 meters per second. So the correct option is option C. Question number 95. At what frequency will an inductor of 10 heavy have a reactance of 200 ohms? So the inductive reactance XL is given by 2 pi Fl, and so the frequency F will be equal to the inductive reactance divided by 2 pi L, and numerical application means 200 ohms divided by 2 pi times 10. This and this simplifies, and at the end we get 10 on pi hertz. So the correct option is option C. Question number 96. Which of the following reasons best explains why alternating current is preferred to direct current for long distance transmission of energy? A. Alternating current can be easily rectified. B. Alternating current is easier to generate. C. Alternating current has no polarity. D. Alternating voltages can easily be stepped up or down. E. None of the above. So the correct option is option D. Question number 97. Two identical insulating spheres, each carrying a charge Q, are separated by a distance r. If the distance is doubled, what will be the ratio of the magnitude of the new force to that of the force before the changes were made? So we get option A 16, option B 1/4, option C 1 on 16, option D 4, option E 8. So let's identify the problem. So we have two identical insulating spheres which are each having a charge Q and are separated by distance r. So I have a sphere which has a charge Q, and I have another identical which has a charge Q, and the distance between them is simply r. So if the distance is doubled, what will be the ratio of the magnitude of the new force to that of the old force? So when they are separated by a distance of r, we get F, I'll call it F1, I'll call it F old, will be equal to K Q squared divided by R squared, where K is a constant, and this is the expression of Coulomb's law between two charges, the expression of the force between two charges. So this is F old, so we'll call that equation 1. So let's get the scenario for F new. So I have the same case, the same scenario Q, and I still have Q, but now the distance between the two charges is doubled, so it becomes 2r, and so we get the new force F new is going to be K Q squared divided by 2r, all of that squared, is going to be K Q squared divided by 4r squared. But this K Q squared this K Q squared on R squared is equivalent to F old. So it means F new, F new is equal to 1/4 F old. And so they said, what will be the ratio of the magnitude of the new force to that of the old force? So it means F new divided by F old will simply be 1/4. And so the correct option is option B. The next Question number 98. The intensity of monochromatic light beam is doubled. Which of the following changes, if any, occurs in the amount of motion of each photon of light? A. Half being doubled. C. No change multiplied by 4. None of the above answers. The correct option is C. No change. The momentum does not change, so the amount of motion does not change. Question number 99. Which of the following statements about a particle of constant mass undergoing uniform motion in a circle is not correct? Option A. The particle has a constant speed. Option B. The particle has a continuously changing velocity. Option C. The particle is subjected to constant force. Option D. The particle has continuously changing kinetic energy. E. None of the above. So the correct option here, what is wrong, is option D. The kinetic energy is constant, since the kinetic energy Ke is a half m omega squared r squared, or simply a half mg squared. And for a body moving in a circular path, the speed is constant and the velocity changes throughout its motion, because it doesn't change in magnitude, but it changes only in direction. So we have, let's say, at this instant the velocity is pointed as such. At this instant the velocity is always a tangent to the circle, and so on and so forth. So throughout the whole motion we observe that there is a change in direction of the velocity. Question number 100. Which of the following statement is true? Of the acceleration of a particle under the influence of the gravitational field produced by a body of mass m. A. It is always proportional to the distance from the center of mass of the body. B. It varies as the square of m. C. Its direction is independent of the direction of motion of the particle. D. Its direction depends on the direction of motion of the particle. E. None of the above. So the correct option is option C. The direction of the gravitational field acceleration G is independent of the direction of the motion of the particle. So this brings us to the end of this video. I hope you enjoyed the video, and see us in the next video. Also, please do not forget to like, share and subscribe. See you in our next video, and best wishes for your entrance exams. Thanks for watching.